This is question from June 21, May-June 21, 9709, variant 31. Question number 5. A part. Solve the equation z square minus 2p iota z minus q equals to 0, where p and q are real constants. So for this solution, as this is quadratic question, for the solution, use the quadratic formula. Minus b plus minus square root of b square minus 4ac over 2a. So here a is equals to 1, the coefficient of x z square. So a is equal to, here a is equals to 1, b is equals to coefficient of z, which is minus 2p iota, and c is equals to minus q, the constant term. So z is equal to minus p minus 2p iota plus minus square root of b square minus 2p iota square minus 4 into a into c divided by 2a. A is 1. Simplify further. 2p iota plus minus, we have 4p square iota square plus 4q whole divided by 2. Iota square is minus 1. So next step is 2p iota plus minus 4p square plus 4q square root whole divided by 2. Next, 2p iota, inside the square root 4 is common. If 4 is common, q minus p square is in the bracket divided by 2. Further, this is 2p iota plus minus 2 outside the square root q minus p square over 2. Further, 2 is common in the numerator. If 2p is common, inside the bracket is pi plus minus q minus p square root whole divided by 2. This 2 goes with this 2, and yes, we have the two values. So z equals to, these are the answers, these are the roots. p iota plus minus q minus p square root, or you may write the roots are z is equals to p iota plus q minus p square, and the other is p iota minus q minus p square. These are the two roots of the equation, roots of the given equation. These are the roots of the given equation. Very simple. The second part is tricky. In an Argand diagram with origin O, the roots of this equation are represented by the distinct points A and B. Given that A and B lie on the imaginary axis, find the relation between P and Q. So we know that the vertical axis is the imaginary axis and the real axis is the horizontal. So we have the real axis, write RE, the real axis, and for imaginary, write IN. So these two roots are represented. These roots are represented by the points A and B in the order. So say this point is A and let the other is B. So these are the points, and these points A and B on the imaginary axis. So imaginary axis means, say one point is here. Say this point is A here, and the other point, as these are distinct, so you may take somewhere else. So this is point P. So these are the points on the imaginary axis. It means there is no real part for this. Now, the roots are, as the roots are, say Z1 is the first root, uh, P iota plus was Q minus P square, and the other is Z2 equals to P iota minus Q minus P square. These two are represented by, say, A and B. So one is A, the other is B. As it is on the, as A and B are on the imaginary axis, so Z1 and Z2 should be completely in terms of I. So they should know any real part for this. So the first thing which can come in your mind that, so as we are looking for on the point on the imaginary axis, so the first thing which can come in your mind that Q minus P square, if Q minus P square is equals to 0, then as a result, Z1 is equals to Pi and Z2 would be again Pi. So this cannot be the case because it's clearly mentioned that A and B are. So if say that A is the Pi is represented by A and Pi is again represented by B. So these two are the same points. But A and B are distinct points. So reject this option because this cannot be the case, because by equating Q minus P square to 0, we're getting the same roots Pi and Pi. So what is the other option then? So what about this square root thing? So the square root thing, as it is on the on the imaginary axis, so this part this part which is Q minus P square here, or Q minus P square, if the answer of Q minus P square is negative, if the answer of the second option, we rejected this option when Q minus P square equals to 0 because we are looking for only the imaginary thing. So if Q minus P square equals to 0, this is not the case because the same answers for the roots. If Q minus P square is negative, if say inside of the square root is negative, so I give an example. Uh, like if inside is minus 4, the square root of minus 4 is 2 iota. So this is in terms of iota, and I'm looking Z1 entirely in terms of iota and Z2 entirely in terms of iota. And this is possible only when this Q minus P square is negative. So then iota terms added to another iota term, it would be iota, which is on the imaginary axis. So Q is less than P square is the relation between Q and P. So if Q is less than P, then the points A and B are on the imaginary axis, and yes, this is the relation. This is how you can answer this part. Third part is, given instead the triangle OAB is equilateral triangle. Given instead, so don't mix up with the previous part P, but keep in mind that this is the common statement. So this is the common statement, and here the triangle OAB is equilateral triangle. O is the origin. So Z1 was Pi plus square root of Q minus P square. Say this is A, and Z2 is P iota plus Q minus P square. This is B. So these roots are represented by the points A and B. So label Pi plus Q minus P square under root as A, and the other with negative, with negative sign as B. OAB equilateral triangle. So OAB is equilateral triangle. I can write these two as, first rearrange q minus, this is just for understanding, plus p iota, this is a, and minus square root of q minus p square plus p iota is b. So for these 2 points, notice that the imaginary parts are equal, same pi and pi. P is the imaginary part. So for this answer, I'm drawing a sketch, and in that sketch, there is origin, imaginary axis is here, real axis is here, origin is here, and the 2 points. So notice one thing that real part is q minus p square and negative is for the other. So one is on the right side and one is on the left side of the imaginary axis. So let us take this point here, 1 point, and the other point here, and their imaginary parts are equal. So you can draw in this way a triangle OAB, and this triangle is equilateral triangle. So after drawing this equilateral triangle, I'm looking for a connection between Q and P, or we want to express Q in terms of P. So here, the point A, the real part is here, which is Q minus P square, and here is the same distance from, but on the left side, minus Q minus P square. So this is equilateral triangle. All lengths are equal. And this is one fact. The other fact is that all angles are 60, 60, and 60. Each angle is 60. So, but I'm using the length idea here. Okay. The other option can be like if we draw the real axis and the imaginary axis. So the other possibility is that we can take a point here and the point here. This is point A. This point is point A. This point is point B. And this is the case when P is negative, but in the question is not mentioned that P is with positive sign or negative sign. So by considering any figure, you can answer this part. Again, all the lengths are equal. So let us consider this part. So the total length from this end, this is equilateral triangle, means all lengths are equal. So the length as q minus p square and q minus p square with negative sign, the total length is, you just add these two lengths. Like if you have minus 2, if you have minus 2 here and plus 2 here, the length is 4. The length is 4. So you just add 2 plus 2 is, so 2 into q minus p square. So this length AB is here. This length is 2 into q minus p square. And the other is the length which you can find by using the distance formula, or if you know the complex number uh, which is represented by A, so you can find its modulus. So I'm writing Z1 over here. This is for A. Z1 is P. It was q minus p square, q minus p square plus p iota, uh, then the magnitude z1, the modulus is q minus p square whole square, formula a square, and like if you have a plus iota b, the modulus of a plus iota b is a square plus b square. I'm using this thing here with a square root. So is equals to q minus p square plus p square with under the root, which is equals to q with under the root. And yes, this is the modulus because this root was z1. So model, this is the length from O to A. Also, the length AB is here. Also, AB length is 2 into Q minus P whole square. This is the length AB. As equilateral triangle, as OAB is equilateral triangle, AB length is equals to OA length. So 2Q minus P square is equals to root Q. So I can square both the sides, squaring both the sides. When you square both the sides, we get 4, 2 power 2 is 4, and square root cancel square. So Q minus P square is equals to Q, which is equal to 4Q minus 4P square is equals to Q. I can simplify 4Q minus Q is equals to 4P square. PQ is equals to 4P square, and finally Q in terms of P, 4P square over 3 or 4 over 3 P square. This is the answer. Express Q in terms of P. So I use the fact that equilateral triangle, all lengths are equal. You can find this length by using the direct approach, or you can apply the distance formula. So why this line is horizontal? So this is important thing. Why this line is horizontal? This line is horizontal. This line is parallel to the real axis because their imaginary parts are equal. So imaginary parts are equal. Imaginary parts are equal. So the height is b, the height is b, or you can write this as, if just this was just for explanation, this is a Q minus P square comma P, and this is Q minus P square with negative sign comma P. So y coordinate is the same, so the height is the same, so this is parallel to the real axis, and you can find the length directly by using the number line concept. This is how you can answer this part. Thank you.